Did you know that vitamin deficiency is one of the major global public health problems, especially in underdeveloped countries? Millions of preschool-age children have a non-apparent deficiency of this vitamin, but vitamin deficiency is not limited to children or underdeveloped countries alone. It is estimated that 1/3 of the world's population has a vitamin deficiency. Progressive vitamin deficiency can lead to night blindness in the eyes. If left untreated, it can cause dry eyes and ultimately lead to total blindness. On the skin, it causes significant dryness, as well as dryness of mucous membranes. People with a vitamin deficiency have an impaired immune system with a higher susceptibility to diseases, especially viral ones. In this video, you will learn about vitamin A, its functions, and its absorption. Vitamin A, along with vitamin D and vitamin K, belongs to the group of fat-soluble vitamins, so-called because they dissolve well in fats and are stored in tissues such as the liver and fat cells. The generic name for vitamin is the result of two compounds. On one hand, there are what we call retinoids, such as retinol, retinol, and retinoic acid, which constitute the retinoids. On the other hand, there is the group of beta-carotenes, which are carotenoids and provitamin A carotenoids, which ultimately, through a process of metabolism, transform into vitamins. Vitamin A is a vitamin that enters our body through food, but how and where is this vitamin absorbed? Being a fat-soluble vitamin, its absorption is related to the absorption of fats, as was also the case with vitamin D. 90% of the vitamin in our body is stored in the liver. When the skin, mucous membranes, or other organs need this vitamin, it is released from the liver and binds to a carrier protein that requires zinc to do so, which has been discussed in another video. This carrier protein carries it to the tissues, and there it is released. So then, what are the functions of vitamin A in our body? Vitamin A is necessary for normal growth, proper immune response, reproduction and fetal development, and it is essential for the proper functioning of the visual cycle. Its functions vary widely across different organs and systems. Firstly, a very important function is its role in gene expression. Different compounds act as hormones, influencing gene expression and thus numerous physiological processes. In reproduction, it controls sperm formation, placenta and fetal growth, and the synthesis of sex hormones. The second function of vitamin is related to growth and development, as it regulates the activity of growth cartilage and, therefore, bone growth. Retinoic acid activates the growth hormone, and retinol and retinoic acid are essential for embryonic development. The third function of vitamin is its crucial role in the immune system, as it is indispensable for its proper functioning. Innate response mechanisms are altered by a deficiency of this vitamin, and this deficiency is related to susceptibility to infections, especially those caused by viruses. Furthermore, it is known that during infections, vitamin A stores are drastically reduced. The fourth function, and probably one of the most well-known, is vitamin A's action on vision and eye health. Vitamin deficiency in children in developing countries is the leading cause of blindness. Early evidence of vitamin deficiency causes night blindness, but if this deficiency is prolonged or severe, it can cause xerophthalmia or dry eye, which can lead to corneal ulcers and total blindness. The fifth function of vitamin is its effect on our skin and mucous membranes. The cells of our skin and mucous membranes act as barriers, the first line of defense between our body and the outside world. Vitamin A regulates the differentiation and proliferation of different epithelia, which are tissues made up of cells that form the skin and mucous membranes. Additionally, it promotes mucus and protein secretion and mucus formation, essential for the proper functioning of our mucous membranes. Vitamin deficiency in these tissues can lead to inflammatory diseases, and if this persists over time, it can lead to chronic diseases. In the skin, it can cause dryness and atrophy of sweat glands, which produce sweat, and sebaceous glands, which produce oil, the nutrients for the skin. This results in a rough appearance of the skin, with excessive keratin formation, such as follicular hyperkeratosis, leading to diseases such as ichthyosis, lichen planus, and psoriasis. All of these skin diseases benefit from vitamin A treatments, together with vitamin E and zinc, producing a much healthier skin appearance together. Furthermore, vitamin E prevents the toxic effects of high doses of vitamin A. For acne, a derivative of retinoic acid is used, which reduces skin peeling, but it has significant side effects and should always be supervised by a dermatologist. The sixth function of vitamin A is its antioxidant action, along with vitamin C and vitamin E, which are antioxidants, meaning they act against oxidation and the release of free radicals. These free radicals are the cause of premature aging and degenerative disorders. Therefore, vitamin A acts as a preventive measure against them. The seventh and final function of vitamin A in our body is the production of red blood cells in our blood. The precursor stem cells of red blood cells and all blood cells depend on retinoids for their formation. Additionally, vitamin A appears to facilitate the mobilization of iron from the body's stores to the red blood cell for the incorporation of hemoglobin and subsequent oxygen transport. Two of the major problems in developed countries, such as vitamin A deficiency and iron deficiency anemia, seem to coexist due to a deficiency of one or both elements. Clinical studies have documented this association. Adults with a vitamin A deficient diet develop anemia despite adequate iron intake. Anemia responds to vitamin A treatment but not to iron supplementation alone. Thus, combining vitamin A with iron appears to improve anemia levels. Furthermore, by adding zinc supplements, as discussed earlier, the transport protein for vitamin A increases. Studies conducted in children aged 6 months to 3 years with recurrent respiratory illnesses showed that supplementation with vitamins and zinc for 4 months reduced the incidence of these diseases. Vitamin A facilitates zinc absorption, but zinc deficiency reduces the protein that transports vitamin A to tissues. In this video, we have seen what vitamin A is, how and where it is absorbed, and the important functions it has in our body. So, if 1/3 of the world's population has a deficiency of vitamin A, how can this deficiency occur? If you want to know the causes of this vitamin A deficiency, learn which foods are rich in its content, and whether supplements are necessary, find out what supplements to take and in what doses, watch the video in which I discuss all this, and you'll have all the information you need. If you like this video, don't forget to click the like button and hit the bell to stay updated on new content.